Okay, if the a is greater than 0, but this time the exponent has a negative in front of it, then that's considered to be exponential decay. The graph is decreasing from left to right. Right? It's still approaching the x-axis like an asymptote. It still has a y-intercept of 1. There's still not a lot of difference whether the base is 2 or the base is 4. It's the same thing. Basic shapes, just kind of like when we deal with the basic shape of a parabola and move it around, right? Same thing here. Basic shape of a exponential decay, and then we'll be able to move it around by adding and subtracting and multiplying and all that stuff. Now, in Algebra 2, it was a little bit different, okay? In Algebra 2, when we wanted to say exponential decay, we said that meant that the a was less than 1. That would have been like saying, I'll say h of x equals 1/2 to the x. That's how we said exponential decay. It was because the base was a number between 0 and 1. But that's the same thing. I mean, 1 over 2 is 2 to the negative 1, right? That's 2 to the negative 1 to the x power. When you raise a power to a power, you multiply. So that's 2 to the negative x. Well, that's the same thing as that. So it's just a different way to write the same thing. Right? In this textbook, they do it by putting a negative exponent most of the time, not all the time. In Algebra 2, it was always, if that number is a fraction between 0 and 1, exponential decay.